Okay, so today we are going to be solving some problems from the book. These are problems from at the end of chapter 4. So I will be solving some of them. I think there are 16 problems in the book. So I will be solving about maybe 4 or 5 of them. And the rest is up to you guys to solve. So I'll get started with number 1. Okay, I'll just use a different ink. So question number 1, rain spoils strawberry crop and as a result price rise from 2 to 3. Okay, so price used to be 2, it's gone up to 3, and quantity demanded has fallen. It used to be 1,000, it has fallen to 600. Okay. So part A, what is the price elasticity of demand? Okay, so PED is equal to, right, so what I am going to request you guys, I'm going to solve this right now, but what you guys can do is pause the video and try to solve this yourself, and then of course you can come back and see me solve it. Okay, so of course the formula is new QD minus old QD divided by new plus old divided by 2. This whole thing will be divided by new price minus old price divided by new plus old by 2. And so what we get is minus 400 by 800 multiplied by 5 divided by 1. This is PED, which effectively gives us 1.25. Just give me a minute. I'll just use a calculator and make sure that I have got it correctly. So okay, and of course remember there is a minus sign, so PED is 1.25. The question doesn't ask us to analyze this, but if we were to analyze it, what we would say is that a 1% change in price of strawberries will lead to a 1.2% change in QD of strawberries. So that's part A. Part B, describe the demand for strawberries. It's elastic, but it's less than -1, so obviously it's elastic. So that was number 1. Number 2, I'm not doing. I'm going to leave that for you guys to solve. It's very similar to number 1, so you should all be able to do it. 3 and 4 also, you guys can give it a go and see if you are able to do it. 5 and 6 are also pretty basic. I'll leave that for you guys to solve. And I'll move on to number 7. So we have, obviously, you see, a demand schedule at different price level, the quantity demanded of chips. So part A, what happens to total revenue if price falls from 400 to 350? Okay. What is the formula for total revenue? It's price times quantity, right? So if price is 400 euros, total revenue is 400 times, what is the quantity? when price is 400, we can see it from the graph that it's 30. And so that gives us a total revenue of 12,000 euros. And if price is 350, total revenue is 350 times, when price is 350, quantity demanded is 35. And that gives us, well, I'll need the calculator again. So 350 times 35, 12,250. Okay, so this is what we find. If price is 400, total revenue is 12,000. And if price is 350, total revenue is 12,250. And I think that's the end of part A. Part B. Oh, no, wait. Question was, part A was, what happens to total revenue if price falls? Okay, so we still have to write down the answer. If price falls from 400 to 350, total revenue increases from 12,000 to 12,250. Now that is the end of part A. Part B, what happens to total revenue if price falls from 350 to 300? Okay. If price is 350 euros, we know that total revenue, we've calculated this already, it's 12,250. If price is 300, total revenue is 300 times quantity. When price is 300, quantity is 40. And that gives us 12,000. So once again, we have to write down the answer. If price falls from 350 to 300, total revenue falls from 12,250 to 12,000. That is the end of part B. Part C. At what price is total revenue maximized? Okay, so there are multiple ways of calculating this. What you guys can do is take each of the price level. So at price 200, QD is 50. At price 250, QD is 45, and so on. So calculate the total revenue of all those cases, and then you can see at which point you get the maximum total revenue. I'm not doing all of that work. You guys can do it, but the answer is, it's going to be when price is 350, total revenue is, of course, you guys will have to do the calculation, which I am not doing. Part D. Average price of 350. Is the demand for chips elastic or inelastic? Use the total revenue test to answer this question. Okay, so this is an interesting question. So what you guys can do at an average price of 350, when do you get an average price of 350? What's happening here? Okay, that's good. So here's the thing. If demand is elastic, increase in price implies fall in total revenue if demand is inelastic. A rise in price implies a rise in total revenue. When total revenue, therefore, when total revenue is maximized, it's not increasing or decreasing. When total revenue is maximized, demand must be unit elastic. If there are some confusions about this, I'm going to encourage you guys to think about it. It may be a little bit difficult to understand properly, and I'm not explaining it even more because I actually want you guys to think about it and read the book. So I'm not explaining this because I'm sure if you guys think about this for a few minutes, you will be able to figure it out. All right, so just give it a go. And let us move on to the next one. So if we've done 7, 8 is exactly the same thing. So you guys can give it a go. Let us try and do number 9. Okay. So once again, I'm leaving 8 for you guys. In problem 7, so the problem that we just solved, at price 250, is demand for chips elastic or inelastic? So here's the thing. Once again, I'm going to do this very quickly. I'm not going to explain in great details. That's because I want you guys to think about it. But if you think about it and if you do the entire thing, what you are going to see is that at price 250, if price goes up, total revenue is going to go up. So at price 250, you are going to have a total revenue. If you increase the price and go to 250 and then calculate your total revenue, you're going to see that it has increased. Similarly, from 250, if you go back and decrease your price, so if price goes down, you're going to see that total revenue has gone down. And when you put these two together, what that is going to mean is that at price 250, demand is inelastic. Okay. Once again, I am not explaining this. You guys should be able to figure out why. Okay, give it a go. Number 10 is exactly the same as number 9, so I'm leaving that for you guys as well. Let's give number 11 a go. Okay, so what we know is that, okay, so price of orange has increased by 12%. Price of orange increased by 12%. Orange smoothie, so I'm just writing orange. Quantity demand of orange smoothie as a result has gone down by 22%. And apples, price of apples, oh sorry, quantity demanded of apples has increased by 40%. Okay, so what we have to find out is cross elasticity of demand between orange smoothie and apple smoothie. You guys remember the formula, which was effectively percentage change in apples divided by percentage change in orange. And of course, usually we write out this, the formula to calculate percentage change, which is old minus new, new minus old divided by old plus new divided by 2, whole thing divided by all the things. So this is effectively what we do. We calculate change in one thing divided by change, percentage change in another thing. And in question 11, percentage change in QD. So quantity demanded of apples have increased by 14%, and quantity demanded of oranges has decreased by 22%. Let me just read the question again, make sure it's correct. Decrease 22% and increase to the 4%. Yep, that is it. And as a result, what we are going to get, if I bring out the calculator again, divided by 22, 63. Okay. 0.64. And there's a minus, of course. So YED is minus 0.64. So what does that mean? First of all, there is a negative sign, which means that apples and oranges are substitute goods. If price of, oh no, I've made a mistake. I've used the wrong formula, of course. This is percentage change in price of oranges. Okay, sorry about that mistake. Price of oranges. So that's 12%. And as a result, what we are going to get is, once again, I'll need the calculator. So 14 divided by 12, that gives us 1.167. Yes, okay. What can we say? First of all, this is a positive HCD, positive cross elasticity of demand. What does that mean? It means that if price of one good goes up, the quantity demanded of the other good will go up as well. So based on the sign, based on the fact that we have a positive sign here, we can say that apples and oranges are substitute goods, and the fact that it is more than one means that it's elastic. So therefore, apples and oranges are elastically substitute. That's the end of number 11. Number 12 is exactly the same. So hopefully you guys can do number 12, 11, 12. So let's move on to number 13.